Okay, in this next section we're going to take transformations, the concept of transformations. We're going to mix a little bit of algebra in with it. Alright, so what we want to do first is work on just doing transforming points. So I'm going to take this triangle that's given, and in the first problem here I'm going to translate it using this vector, -2, 5. And this is called vector notation, which basically means that you're going to take each of the points and you're going to move -2 in the x direction, +5 in the y direction. Okay, that'll give you a magnitude and a direction for our vector. Okay, so for example, I'm going to take point A, I'm going to go down, to the left 2, and I'm going to go up 5. Okay, and so this is my first point here, and then this may be my A prime. The next thing is to take B and go 2 in the negative x direction, and then 1, 2, 3, 4, 5 in the y direction. So there's my B prime. Then C, I'm going to do the same thing. -2, 1, 2, 3, 4, 5, and there's my C prime. So there's my, after one translation, there's my new triangle. So I basically slid it over to there. And then I'm going to go ahead and take each of these and I'm going to apply this transformation, this translation, and by this vector. So it's going to be take B and go -3, 1, 2, 3, and then down -11. So I'm going to be down to -5. Take A, move it to the left 3, 1, 2, 3, and then I'm going to go down 11. And then that's my A double prime. This one is my B double prime. And my C, I'm going to go 2, 1, 2, 3, and then down 11. So there's my C double prime. And there's my final points, my final figure there, after doing a translation, 2 translations. If you notice, what I could have done here is I can actually combine these 2 vectors together, and what I could have done was just taken the x coordinates, the x part of it, and added them together, -5, and then added the y's together and gotten -6, and just applied this vector on the original figure, and I would have gotten the same answer. If you're looking for the points, I think the points end up being for A double prime, -2, -1. For B double prime, it's -1, -5, and then C double prime is -5, -3. Okay, the next thing I'm going to do here is we're going to look at reflections. So I'm going to go ahead and reflect the same figure over the line x = 0 first. And the line x = 0 is simply the y-axis right here. So if I reflect this, the C is not going to go anywhere. It's because it's on the on the y-axis, excuse me. And then I'm going to reflect the point A over to here. That's going to be A prime. And then B is going to end up over at -4, +1, B prime. And the figure looks like that. And then what I'm going to do is I'm going to reflect it over the line y = x. The line y = x has a slope of 1 and a y-intercept of 0. So it's basically this 45-degree line that goes like this. Okay, and what you're going to find out is that I can just take the X and the Y and just flip them. But okay, let's see, I'm going across this way. It's going to be at, instead of at 0, 3, it's going to be at 3, 0. And this one's going to go across the line. It's going to be at, instead of -4, 1, it's going to be at 1, -4. Right there. And the A is going to be at, see, it's currently at -3, 5, and so we're going to go to 5, -3, and there's my other point there. So all I did was I took all the X's and all the Y's and just flipped them, and I ended up with my remaining figure. So in the end, I ended up with 5, -3, 1, -4, and 3, 0. All right, moving on to rotating. So if I take this figure here and I rotate it 90 degrees clockwise, so clockwise is in the direction that the hands of the clock are moving, and I rotate it 90 degrees around the origin. If I think about it as like a, here's the hand of a clock. If it's rotating 90 degrees, it'll end up over there. So that's where my new point C prime is going to end up. Same thing with the B. If I take this and create like a little hand of the clock here, it's going to rotate 90 degrees and it's going to end up right there. That's going to be my B prime, where this is going to be 90 degrees. And then lastly, if I take my A prime and rotate it, it starts at 3, 5, so I'm going to go 5, 3, something like that right there. And that's going to be my A prime right there. Okay, connect the dots, and that's my new triangle, rotated 90 degrees clockwise around the origin. And then the last one is dilating this triangle centered at the origin by a factor of 1.5. So the nice thing is, because it's centered at the origin, I can just take each of the points and just multiply all the coordinates by 1.5. So, because what's going to happen here, for example, the C is going to be multiplied by 1.5. It's going to be 1.5 times as big as this. So I'm going to end up right there at 4.5. So it's going to be 0, 4.5. Or I can simply multiply 3 times 1.5. Same thing with the B. It's going to be 1.5 times this. It's going to be somewhere out there. I just take the two coordinates, multiply by 1.5, so I end up with 6 is this, and then it's going to be up 1.5. So right there. And then same thing with my A. It's going to end up going this direction, but 1.5 times the length from the origin, and it's going to be 4.5, comma 5 times 1.5 is 7.5, and so 4.5, 7.5 is going to end up right there. Connect the dots, and there is my dilated triangle around the origin by a factor of 1.5. Okay, let's move on to the next page, and we'll go grab a couple of these problems on the back. Okay, moving on to the back side, we're going to grab a couple problems here. The first problem here, you're supposed to graph this point, 5, -2, which is right there. And the second point is 1, 4, which is right there. That's S prime. And what we're supposed to do is we're trying to figure out the line of reflection. So basically, there's going to be a line that this point here reflects over to get to this point. And we know that this line is going to look something like this. Okay. And I think we can agree that the properties here are that these two from here to here and here to here are exactly the same length. And so this is a midpoint, and that this is a right angle here, so they're perpendicular. So if I do that, I know that to find this line of reflection, I need two things, right? I need a point, which I can get from the midpoint, and a slope, which I can get from finding the slope of this one and then doing the opposite reciprocal. So let's do that. So the midpoint, is going to be the average of the x's and the average of the y's. So it's going to be 3, 1, right? 5 plus 1 divided by 2, and negative 2 plus 4 divided by 2. And then the slope of the green segment from the 2 points is going to be 6 over negative 4, which simplifies to negative 3/2. So I know that the slope of the perpendicular, the red line, is going to be the opposite reciprocal of that, so it's 2/3. Plug it into point slope form, y minus 1 equals 2/3 times the quantity x minus 3, and I'm done. That's the equation of the red line. Let's take a look at number 4. Number 4 is kind of a similar problem to this. Let's graph these points and the line. So if I take this point, 6, negative 5, it's right there. And let's graph this line. It's going to be negative 3 is the y-intercept. Get a different color here. Negative 3. And it's going to be down 2 over 1, down 2 over 1, down 2 over 1. Connected like that. And I want to reflect the point A over that line. So it's going to end up somewhere around here and get an A prime. Now I could try counting and maybe get lucky if it's possible that this might be the point, that's the midpoint, but we don't know. So let's see if we can figure this out without just guessing. Okay, and what we need to do is we need to find the equation first of this blue line, and then once I find the equation there, I can find that point right there by solving a system. So go ahead, and I already know the red line is this one. Okay, so the red one is this one. The blue one, I know a point. The point is A, so here's my point. It's 6, negative 5. And I know the blue slope is just going to be opposite reciprocal from the red line slope. The red line slope is negative 2, so it's going to be positive 1/2 will be the slope of the perpendicular. So my equation is going to be y plus 5 equals, I'm just putting this into point slope form, 1/2 x minus 6. Now if I bring this equation down here, y equals negative 2x minus 3, and I can just solve that system. I can use substitution. It seems like that would make sense. Plug that in right there since it's all set up for that. And I'm going to solve this thing. When I solve this thing, I'm going to get x equals 2, y equals negative 7. So 2, negative 7 is my intersection. It does look like it actually hits that point there. So if we had guessed that, we would have gotten lucky. But we actually showed it. It's true algebraically, which is nice. And then finding this point here just becomes a matter of counting, because all I'm going to do is I know that it's got the same slope and it's the same distance from this line that's reflected over. So I'm going to go down 2 and to the right, to the left 4, and now I can go from here down 2 and left 4 again. And once I do that, I find my A prime, which ends up being equal to -2, -9. And that's it. Okay, if you have any questions, make sure you contact me. Otherwise, I'm going to let you go ahead and try some problems here. Okay, take care.